Alright guys, welcome back to another video on the NeetCode's channel. Today we're going to be solving LeetCode number 167 to sum 2, which states that given a one-indexed array of integers, numbers, that is already sorted in non-decreasing order, we want to find two numbers such that they add up to a specific target number. And we want to return the indices added by 1. And there's exactly one solution, and we can't use the same element twice. So again, if the target was 4 here, we couldn't use 2 and 2 again. It just wouldn't work. Okay, and we can only use constant extra space. Okay, so essentially for the solution, we're going to start by building up from the naive solution. So the naive solution, what we would do is we would compare each pair of values until we get our target. So essentially over here we'll consider this pointer 1 and this pointer 2, and what we'll do is we'll consider the sum of these two values. So in this case it would be 11, and then we'd move the pointer, and then we get 21, move the pointer, 31, move the pointer, and then get 51. But at this point, what's important to note is we've already passed our target value. Now, we know that none of these values could possibly ever add up to 40, because we've checked that it doesn't add up to 40 with the smallest element. So if one of the elements is already over the target value, or when added with the smallest element, gets us over with the target value, it cannot possibly be added with some other value to get us the target. Okay, and then essentially what we've done now is we've reached the end of the array, but we haven't found our target. Then we move the other pointer. So it starts off at 10, pointer starts at 20. Now this gets us 30, obviously not our target, still under, so we keep it moving. Okay, so then 10 plus 30, this actually gets us our target value, so then all we do is return here. Now, since we know that we can achieve O of n time, and we need an algorithm that uses O of 1 space, we instantly know that we can't actually be storing these values in between to reduce the amount of computational work being done in the future. So we need another way of getting rid of repeated work. What we'll consider now is, okay, do we need to be looking at these middle values every time? So what about the current algorithm we have set up allows us to reduce the size of the array on the right? We know that the right pointer plus the left pointer, when the right pointer points at one of these values, is greater than our target. So it's just not possible to for any values to the right of these to work out. So essentially we can entirely avoid looking at these values over here just by actually starting from the right side of the array, because now we know that, let's just say if we start at 70 and it's over, well, this won't work. 50 and over, this won't work when added with 1. 30, well, this is now under. Okay, so then what would we do in this situation? So since we're now under our target, what we know is that, well, 1 won't work with any other value. So if one pointer is pointing at 1, it simply will not work with any other values, just due to the fact that the other pointer will also make any value in the array added with 1 less than our target value. Okay, so the next step would be to consider the value of 10, and also, while we're here, crossing out the value of 1, because we know that no value added with 1 adds up to our target value. Okay, so what about 10? Well, let's consider 10 plus 30. Well, that works right away. So the idea here is that we can just reduce the array, so to the right of the right pointer and to the left of the left pointer, those values cannot be present in a target. Since we do this in essentially one pass, the time is O of n, and since we're only keeping track of 2 pointers, the space is O of 1. Okay, now for the code solution. So essentially what we want to do is we want to start off by creating 2 pointers. So pointer 1 is equal to 0, and then pointer 2 is just equal to the length of numbers array minus 1. Okay, and we want to continue moving the pointers closer to one another just until they have met up. But in this case, they will not meet up just because we have a solution. And if they were to meet up, then we'd exclude everything to the right of one pointer and everything to the left of another pointer from being part of the solution, and the value that it's pointing at cannot be used twice, so that wouldn't produce a solution. Okay, so now what we want to do is we want to continue while pointer 1 is less than pointer 2, and what we would like to do is we would like to consider, okay, is the sum of the two values greater than our target? Is it less than our target? Is it equal to our target? So first, if numbers at index pointer 1 plus numbers at index pointer 2 is equal to our target value, simple, we just return the two pointers. So pointer 1 plus 1, since it's one index, pointer plus 1, and then if numbers at index pointer 1 plus numbers at index pointer 2 is greater than the target value, well, then we would just like to move the right pointer. So pointer 2 minus equals 1. And then otherwise, we've reached the case where numbers at index pointer 1 plus numbers at index pointer 2 is less than the target. So what we would like to do in this case is move the left pointer. So pointer 1 plus equals 1. Okay, and we have covered all of the cases over here, and this should produce the solution every time, just since we're guaranteed a solution. And as we can see, the space is only constant and the running time is linear. And after submitting, as we can see, the solution passes. And yeah, so I'll catch you guys in the next video. Thanks so much for watching. Peace.